Look up, way up. The clouds you see in the sky, the wind that is moving the trees, or the flag in your schoolyard, even the sunshine you feel on your face. These are all a result of Earth's atmosphere. So, at first, we have to know about atmosphere. The word atmosphere is derived from Greek word atmos meaning vapor and Latin word sphaera meaning ball or sphere. It is a layer or set of layers of gases surrounding a planet or other material body that is held in place by the gravity of that body. Earth's atmosphere stretches from the surface of the planet up to as far as 10,000 kilometers or 6,214 miles above. After that, the atmosphere blends into space. Not all scientists agree where the actual upper boundary of the atmosphere is, but they can agree that the bulk of the atmosphere is located close to the Earth's surface, up to a distance of around 8 to 15 kilometers or 5 to 9 miles. While oxygen is necessary for most life on Earth, the majority of the Earth's atmosphere is not oxygen. Earth's atmosphere is composed of about 78% nitrogen, 21% oxygen, 0.9% argon, and 0.1% other gases. Trace amounts of carbon dioxide, methane, water vapor, and neon are some of the other gases that make up the remaining 0.1%. The atmosphere is divided into 5 different layers based on their temperature. The layer closest to Earth's surface is the troposphere, reaching from about 7 to 15 kilometers or 5 to 10 miles from the surface. The troposphere is thickest at the equator and much thinner at the north and south poles. The majority of the mass of the entire atmosphere is contained in the troposphere, between approximately 75 and 80%. Most of the water vapor in the atmosphere, along with dust and ash particles, are found in the troposphere, explaining why most of Earth's clouds are located in this layer. Temperatures in the troposphere decrease with altitude. Daily change of weather takes place due to mixing of air. It is also called the weather-making layer of the atmosphere. Fast-moving winds called jet streams are present in this zone. The stratosphere is the next layer up from the Earth's surface. It reaches from the top of the troposphere, which is called the tropopause, to an altitude of approximately 50 kilometers or 30 miles. Temperatures in the stratosphere increase with altitude. A high concentration of ozone, a molecule composed of 3 atoms of oxygen, makes the ozone layer of the stratosphere. This ozone absorbs some incoming solar radiation, shielding life on Earth from potentially harmful ultraviolet light and is responsible for the temperature increase in altitude. The top of the stratosphere is called the stratopause. Above that is the mesosphere, which reaches as far as about 85 kilometers or 53 miles above Earth's surface. Temperature decrease in the mesosphere with altitude. In fact, the coldest temperatures in the atmosphere are near the top of the mesosphere, about minus 90 degrees Celsius or minus 130 degree Fahrenheit. The atmosphere is thin here, but still thick enough so that meteors will burn up as they pass through the mesosphere, creating what we see as shooting stars. The upper boundary of the mesosphere is called the mesopause. The thermosphere is located above the mesopause and reaches out to around 600 kilometers or 372 miles. Not much is known about the thermosphere except the temperatures increase with altitude. Solar radiation makes the upper regions of the thermosphere very hot, reaching temperatures as high as 2000 degrees Celsius or 3600 degree Fahrenheit. Ionization occurs in this layer. So, electrically charged particles of ions and electrons are found here. The polar lights called aurora borealis and aurora australis of northern and southern hemisphere respectively are developed in this layer. The uppermost layer that blends with what is considered to be outer space is the exosphere. The pull of the Earth's gravity is so small here that the molecules of the gas escape in the outer space.